I'm Kendrick. I obtained PhD in physics.
Hi, my name is Ashwin. I'm the inventor of the loudspeaker.
Hi, I'm William. I'm Howard top student.
Speakers come in all different shapes and sizes, enabling you to listen to your iPod, enjoy a film at the cinema, or hear a friend's voice over the phone. In order to translate an electrical signal into an audible sound, speakers contain an electromagnet, a metal coil which creates a magnetic field when an electric current flows through it. As you can see in the diagram drawn above, electrical energy is converted into sound energy. This coil behaves much like a normal permanent magnet, with one particularly handy property reversing the direction of the current in the coil, which flips the poles of the magnet. As you can see, the current flows from the north to the south pole.
Inside the speaker, permanent magnet is placed behind the cone. The permanent magnet is fixed firmly into position, whereas the electromagnet is mobile. As pulses of electricity pass through the coil of electromagnet, the direction of its magnetic field is rapidly changed. This means that it is in turn attracted to and repelled from the permanent magnet, vibrating back and forth. As you can see, the first direction is attracted to and the second one is repelled.
The electromagnet is attached to a cone made of flexible materials such as paper or plastic. This material will amplify this vibration. Pumped sound waves into the surrounding air and towards you. As you can see from the left, the waves represent the sound. Next, the frequency of the vibration governs the pitch of the sound producer. The amplitude affects the volume. So, when you turn your stereo up high, and you will eventually be able to see the diaphragm covering the cone moving. As conclusion, the amplitude increases, the volume increases, which is why you can hear it louder.
In order to calculate the wavelength of sound wave of the speaker, we need to use this formula. Lambda equals to C over F. Lambda represents the wavelength. Which with the unit of meter. For C, which is the speed of the sound, represent F as meter per second. For F is frequency. With the unit of percent. So here's an example. To find the wavelength, which is the wavelength. Lambda. Secondly, to calculate the frequency of sound wave of the speaker. As the previous equation, lambda equals to C over F. We now converts to frequency equals to C over lambda, which is this frequency, and this is the speed of sound, and this is the lambda. For example, this is the lambda, and this is the frequency. The higher the lambda, the lower the frequency.
Michael Faraday was an English physicist working in the early 1800s. He worked with another scientist named Sir Humphrey Davy. Faraday's big discovery happened in 1831 when he found that when you change a magnetic field, you can create an electric current. He did a lot of other work with electricity, such as making generators and experimenting with electrochemistry and electrolysis. Faraday's experiments started with magnetic fields that stayed the same. That setup did not induce current. It was only when he started to change the magnetic fields that the current and voltage were induced. He discovered that the changes in the magnetic field and the size of the field were related to the amount of current created. It is also known as magnetic flux. Magnetic flux is a value that is the strength of the magnetic field multiplied by the surface area of the device.
Any change in the magnetic environment of a coil or wire will cause a voltage EMF to be induced in the coil. No matter how the change is produced, the voltage will be generated. The change would be produced by changing the magnetic field strength, moving a magnet towards or away from the coil, moving the coil into or out of the magnetic field, rotating the coil relative to the magnet, and etc.
In the following video, we will be showing applications and experiment of the last speaker.
We are doing experiment to the power of 6, which is we are doing 6 different kinds of experiment.
We will be using 3 devices for this experiment.
For the first one, PA system.
Second one will be loudspeaker.
And third one will be the phone.
In experiment 1, we are going to be testing the loudness of 2 speakers. Two speakers have been placed opposite each other to show that they are not their sound waves are not combined. As we increase the volume of the speakers, this will show that the current volume of the speakers will be shown in the experiment. When we combine the speakers together, a larger output is produced, thus creating a louder sound. As conclusion, we can conclude that 2 sound waves overlap from one another from each speaker, therefore a louder sound is produced, which is also called constructive interference.
Experiment 2. The range of the sound wave. When two speakers is brought closer, the range of the sound wave is lowered. But if the speaker is brought far apart, the range of the sound wave is higher. As you can see, when both of the speakers is brought far apart, the range of the sound wave is actually higher, so that it can be easily to be heard. But however, if both of speakers is put nearby each other, the range of the sound wave is lower, as you can see from the diagram.
In our third experiment, we are testing the frequency of audio. There are two different types of frequency wave. For the first one, which is high frequency wave. Here is the example. As you can see, that's the period of the frequency. And we label it frequency. As we know that frequency, formula of frequency is F equals to 1 over T. The shorter the period, the higher the frequency. For the second frequency wave, which is low frequency wave, here's the example. We label that as period. And frequency is labeled there. As we can see, the longer the period, the shorter the frequency.
Experiment 4. Application of loudspeaker in an airport. This is a PA system. Attention ladies and gentlemen, this is the final boarding call for Mr. Kendrick. I repeat, this is the final boarding call for Mr. Kendrick.
Experiment 5. Application of loudspeaker by using phone.
Hi, Kendrick.
Hey, Willem. Are you skipping Mr. Mo's class?
Yes, we should.
Oh, you shouldn't. Mr. Mo teaching is fun and interactive. You should come to class.
I think so too. We should not skip. Let's go to class.
Okay, I'll see you in there.
Okay, goodbye.
Bye.
Thank you for watching our video.